Ready to level up your DevOps skills? Welcome to K4 Coding Academy. Master Kubernetes, Terraform, and AI. Get real-world platform engineering projects. Subscribe now and start mastering your future.
Welcome to Terraform for platform engineers. Automate, provision, and scale your infrastructure as code. Master multi-cloud with AWS, Azure, and Google Cloud. Code your infrastructure. Build the future.
Okay, let's dive right into this explainer. Look, if you've been anywhere near cloud infrastructure lately, you already know Terraform is the absolute backbone of how we build things. But as our organizations scale up, and especially as we're all rushing to support these massive new AI workloads, the way we use it really has to evolve. So today, we're going to see exactly how Terraform is perfectly positioned to solve the unique, frankly massive scale challenges of modern platform engineering. We'll be looking at the exact blueprints the best teams are using to scale safely. Let's get into it.
Now, the sheer scale of the challenge staring us down as we look toward 2026, it's just staggering. Suddenly, we're faced with outfitting infrastructure for large language models and heavy AI applications. And, this isn't just about spinning up a database anymore. We're talking GPU orchestration, model versioning, inference optimization, and we have to do all of this without bottlenecking our developers. The velocity required here, it's completely unprecedented.
Because of this, LMOps is really emerging as a distinct operational discipline. The stakes have fundamentally changed. Platform teams now have to treat AI-native infrastructure with the exact same rigor as traditional compute. I mean, you can't just have data scientists clicking around a cloud console manually provisioning resources anymore, right? It absolutely has to be integrated flawlessly into a unified delivery pipeline.
Section 1. App teams versus platform teams. Let's look at the friction.
So, to solve this massive scaling problem, we first need to understand the fundamental friction sitting right at the heart of our engineering orgs. It's pretty simple. App developers just want to code and ship. They care about their app lifecycle and moving fast. But on the flip side, platform engineers are literally losing sleep over governance, risk, compliance, privacy, and those absolutely terrifying end-of-month cloud bills. The app team wants speed. The platform team needs control. And this friction is exactly why traditional infrastructure provisioning just breaks down at scale.
The crucial point here is that we have to bridge this gap, and we do that through platform engineering. It's all about building an internal product that offers true self-service to developers. This lets them move at warp speed while keeping the control, security, and standardization firmly in the hands of the platform team. And the absolute best tool to build these building blocks? It's Terraform.
Section 2. Building module abstraction stacks.
Now, to actually make self-service work, you can't just hand developers raw Terraform code and wish them luck. You have to use Terraform's real superpower, the module abstraction stack. It's kind of like a layer cake of infrastructure. Down at level 1, we have our primitive modules. Actually, scratch that. Think of these as the raw materials, your VPCs, subnets, raw IAM roles. They require deep expertise to configure safely. Then level 2 steps it up to component modules, like an ECS service bundled with a load balancer. But level 3, that's where the magic happens. These are self-service modules. This is highly opinionated infrastructure where a developer literally just says, hey, I want a web app with a database, and Terraform handles the dozens of underlying resources totally automatically. By wrapping up these level 3 modules, platform engineers create what we like to call golden paths. A golden path is basically your secure by default route. It includes everything an app needs: container orchestration, load balancing, caching, mandatory monitoring. Because it covers about 90% of use cases, app teams can just sprint forward without constantly tripping over security reviews. The best practices are already baked right into the Terraform code.
Section 3. The GitOps orchestration workflow.
Okay, so having these brilliant modules is great, but how do we actually deploy them without causing absolute chaos across our environments? Well, we need a system of record and a system of execution, and that brings us to the GitOps workflow. This is how you industrialize your cloud management. Instead of someone running commands on a laptop, a developer just submits a pull request. Instantly, an orchestration engine generates a Terraform plan. Then, automated policies check that plan. And finally, if everything passes and gets approved, the changes are explicitly applied. Every single infrastructure request becomes a standardized, reviewable code change right inside your version control system.
Now, the industry talks a lot about tools like Crossplane, which, offer a continuous Kubernetes reconciliation loop for infrastructure. And that is incredibly powerful. But Terraform gives platform teams highly explicit orchestration. You know exactly what's going to change before it happens because of that Terraform plan step. For regulated environments or teams that just need strict audit trails, having this explicit control over when and how changes hit production is a massive, massive advantage.
Section 4. State management and guardrails.
Let's dive into the absolute most critical part of Terraform at scale. Seriously, if you get this wrong, nothing else matters. We have to talk about protecting the state file. We've all heard the horror stories, or maybe you've lived them. The reality is, state file disasters don't happen on day 1. They happen in month 9, when multiple teams are layered on and someone decides to run a Friday afternoon laptop apply to fix a broken pipeline. Yikes. Because the state file is the ultimate source of truth for your cloud, any corruption or drift here is literally an existential threat to your entire system.
So how do we prevent that nightmare? By strictly managing our blast radius. You absolutely must isolate your state files to match your ownership boundaries. Whatever you do, never put your core network stack and your application stack in the same state file. If you do, a simple mistake by an app developer could accidentally wipe out your entire production VPC. Instead, use remote state data sources to pass information, like VPC IDs, between stacks. Keep the actual state files rigidly separated.
And to further protect ourselves, we use automated policy enforcement. We're talking about tools like Open Policy Agent, Sentinel, or TFSec. These sit perfectly between the Terraform plan and apply phases. By injecting these checks, we essentially build an invisible electric fence. It actively scans the plan and completely blocks unencrypted databases, missing tags, or misconfigured AI workloads before they ever deploy. The app team gets immediate feedback, and the platform team maintains total, absolute control.
Section 5. Internal Developer Portals.
Finally, how do we completely hide Terraform from the application developers who frankly just don't want to learn it? Well, we top off our infrastructure layer cake with an internal developer portal, or IDP. Using tools like Backstage or HCP Waypoint, we take those level 3 self-service modules we talked about earlier and put a really nice interface right on top of them. So now, a Java developer or an AI data scientist can literally just click a button, fill out a simple form, and boom, they get their database or GPU cluster. The portal talks directly to the GitOps pipeline, and Terraform handles all that complex orchestration silently in the background. It even handles day 2 operations like deployments and rollbacks without ever exposing the backend complexity. It's brilliant.
Section 6. Terraform Platform Engineer Summary.
All right, let's bring this all together. If you're tasked with building a resilient, scalable internal platform, here is your summary blueprint. First, remember that culture eats tools for breakfast. Treat your platform as a product and your developers as your customers. Use Terraform to abstract complexity into those 3-tier modules. Automate your approvals and deployments with a strict GitOps workflow. Lock down your state files to heavily limit your blast radius. And finally, enforce security natively using policy as code. If you do all this, you empower your developers to move at incredible speeds, all while keeping the enterprise perfectly safe.
So here's the question you really have to ask yourself. As we scale into this AI-driven future where LMOps demands faster, way more complex provisioning than ever before, are your golden paths truly ready to carry the load? The teams that master these Terraform abstractions today are absolutely going to be the ones shipping the innovations of tomorrow.
If this explainer helped you rethink your platform architecture and state management, please hit that like button, share this with your platform engineering team, and subscribe to the channel so we can keep bringing you the best, most structured engineering breakdowns on the web. Thanks for learning with us, and we'll catch you in the next one.